Hello everyone, I am Pallavi Boro from Guwahati University. Currently I am doing PhD in the Department of Applied Sciences under Guwahati University and my field of research is nanoscience and nanotechnology. Today I am going to present a poster and the topic of the poster is the effect of variation of reaction time upon synthesized PVA, CDA, ZNS core shell nanoparticles. Here PVA means polyvinyl alcohol, CDS means cadmium sulphide nanoparticles and ZNS means zinc sulphide nanoparticles. That means simply we can say that we want to see how cadmium sulphide, zinc sulphide core shell nanoparticles are dependent on the variation of reaction time during the synthesis processes. Before going to synthesis part, we have to know what are cadmium sulphide materials and what are zinc sulphide materials as well. Cadmium sulphide materials are group 2,6 semiconductor material and it has a direct band gap of 2.42 electron volt. On the other hand, zinc sulphide materials are also group 2,6 semiconductor material and it has a direct band gap of 3.68 electron volt. Although there are a large number of synthesis processes, we have chosen a very simple method known as the chemical reaction method to synthesize the samples. To synthesize cadmium sulphide, zinc sulphide core shell nanoparticles, firstly cadmium sulphide nanoparticles were synthesized. To synthesize CDS nanoparticles, 1 gram of polyvinyl alcohol was mixed in 50 ml distilled water. Then the solution was stirred in a magnetic stirrer for 3 hours until it became clear. Then solution of 1 gram cadmium chloride and 1 gram sodium sulphide solution which were separately prepared were deposited over the core cadmium sulphide nanoparticles which will form the cadmium sulphide zinc sulphide core shell nanoparticles. After that, color sensed was observed by us and we observed that the color sensed from orange to light yellow. That means when color changes from orange to light yellow, then it will indicate that cadmium sulphide zinc sulphide nanoparticle has been formed. During the whole synthesis process, polyvinyl alcohol was used as a capping agent to prevent the agglomeration and distilled water was used as the solvent in our synthesis process. For zinc sulphide nanoparticles to form, zinc chloride and sodium sulphide were used as the zinc source and sulphur source respectively. After the synthesis process, we also perform some characterization tools to characterize the samples. Here we have synthesized 5 CDS ZNS core shell nanoparticles varying the reaction time from 1 hour to 5 hours. To study the optical properties, UV visible spectroscopy and photoluminescence spectroscopy were performed. And to study the morphology of synthesized cadmium sulphide zinc sulphide core shell nanoparticles, XRD analysis and SEM analysis were also performed. To study the optical properties, we characterized the sample firstly by UV visible spectroscopy. We calculated the band gap of each sample using the Tau's relation. We observed that as the reaction time increases, the absorption edge of each sample increases and correspondingly the band gap decreases from 4.23 electron volt to 2.37 electron volt. And this band gap was calculated using the Tau's relation and this was obtained from the UV visible spectroscopic data. PL analysis were also performed for each sample. We observed that some intense peaks were obtained at wavelength in a range of 322.86 to 324.32 nanometer as the reaction time increases. These intense peaks were obtained due to the excitonic recombination of electron and hole pairs. Other 3 less intense peaks were also obtained in a range of wavelength 410.38 to 411.32 nanometer. These peaks may be due to the impurities present in the crystal. This is known as the defect level emission peaks. XRD analysis was also performed to obtain the average crystallite size and to see the diffraction angles and also the corresponding reflection planes of the synthesized CDS core shell nanoparticles. We calculated the full width half maxima from the XRD plot. We observed that the diffraction angles were obtained at angles 2 theta is equal to 28.50 degree, 48.09 degree and 52.17 degree, and the corresponding reflection planes to these angles were obtained as 111, 220 and 311. We observed that these angles match with the standard cutoff cadmium sulphide and zinc sulphide nanoparticles respectively. The average crystallite size was calculated using the Weisser's formula, and we obtained that the average crystallite size of synthesized CDS core shell nanoparticle is 11.87 nanometer. Same analysis was also performed to see the shape and size of the synthesized CDS core shell nanoparticles. We observed that the shape is more or less spherical and the size was in a range 29 to 68 nanometer. So, as a conclusion from the characterization results, we can say that as the reaction time increases for CDS nanoparticles, absorption edge also increases and band gap decreases. From the PL analysis, as a result, we can say that as the reaction time increases, intensity also increases. We followed some papers which are mentioned in the poster. The author Pallavi Boro is thankful to CSIR NET Delhi for the financial support under the JRF NET scheme. Also, we are very thankful to the Department of Applied Sciences, the Department of USIC and Instrumentation, the Department of Chemistry of Guwahati University for providing us the data of UV analysis, PL analysis, XRD analysis and SEM analysis. Thank you very much. Hello everyone, I am